Hello. So this is going to be the first lesson from chapter 5, lesson 1, and this one is actually on lines. I started with my vocabulary terms over on the right-hand side so far. I apologize if the video camera shakes just a little bit. We're going to try this and see how it works. If I have to change something, I will do that later. However, when it comes to lines, honestly, once you figure them out, once you understand what all of these things mean, they tend to be really easy. So the first thing that you have here are your perpendicular lines. Perpendicular. If you have not learned this before, this is two or more lines that create a 90-degree angle. That is very, very important. You have perpendicular lines everywhere. You even have them on this paper. Okay? A perpendicular line is like this red line. Whoop. And the blue line that intersects it. Lines can intersect at many different angles, but a perpendicular angle is a very important one. Perpendicular is 90 degrees. Your parallel lines, those are the lines, if you don't remember, that never touch. Paper just like this has all sorts of parallel lines. The parallel lines that no matter how far they extend, they will never ever touch each other. I also put these arrows on both sides of the lines because they are important. They are representing the lines that never stop. If they have an end point on them, it turns it into a completely different thing. Parallel lines never touch. Now, there are a lot of other words over here on this list. The first one that is probably a little bit daunting is this T word here, transversal. Okay, now, when it comes to a transversal, let's define it first. Transversal. It is a line that intersects two or more lines to create eight angles. Now that sounds kind of weird, but here you go. If I have my two parallel lines, it is a lot easier and there's a lot more stuff that goes on when those two lines are parallel. Our two lines starting here, I'm going to label them L and M. And my transversal is this diagonal. Intersects and cuts those other two lines. Okay, now all of a sudden, I have 8 angles that have formed. My 8 angles are here. 1, 2, 3, 4, 5, 6, 7, 8. Oh, and I forgot to label N. Now, each one of these angles is actually related to all the rest of them. That is where all of these come in handy. All of these terms and all of these phrases represent these angles in here. If I were to know one measure, just one, if I were to know one measure of any of these angles in here, I would automatically know all the rest of them. That's what makes this kind of geometry so cool. Because honestly, all you need is one, and you've got all the rest. So, let's move on to interior angles. interior angles are kind of like they sound. An interior angle is on the inside. Interior angles on the inside of the parallel lines. Okay, so my interior angles here, inside of the parallel lines, 3, 4, 5, and 6. They're on the inside. Okay, in our example, angle 3, angle 4, angle 5, angle 6. And that's it. That's all there is to interior angles. Okay? Exterior angles. I'm going to run out of colors, but that's all right. Move it on up here a little bit. Exterior angles. If interior are on the inside of the parallel lines, exterior are on the outside of the parallel lines. Exterior, outside. Exterior, outside. On the outside of those parallel lines. In our example here, it would be angles 1, angle 2, angle 7, angle 8. Boop. Okay. Now, at this point, now we have alternate interior, alternate exterior, and corresponding angles. Those are all special because depending on which angles you're talking about, they are related. They are equal to each other, or they equal 180 degrees. If we can think about this right now, we have lines here, right? If you don't remember what the angle measure of a straight line is, which is silly, I know, because it's just a straight line. But a straight line also equals 180 degrees. 180 degrees. Okay? Straight line equals 180 degrees. That is important. If we forget that, or better yet, if we forget our alternate interior, alternate exterior, or corresponding angles, we can always fall back on our 180 degrees. Because if we think about it, technically speaking, we got a lot of straight lines here. Straight line, even this one here, straight line. So I have to know that my angles added together have to equal 180 degrees. My angles added up together have to equal 180 degrees. Let's get to our alternate interior angles. Alternate interior angles. I want to make sure that we can see here. Yeah, there we go. Alt or alternate interior angles are just that. If I know what my interior angles are on the insides of my parallel lines, here's my interior, okay? Now I need alternate interior angles. Those are angles on the inside still, but on alternate sides of the transversal. So, inside. They're on the inside of my parallel lines. My alternate interior angles, my two pairs here, I have, in my example, if I start with angle 3, on the inside, but on the other side of the transversal is angle 6. Angle 3 and angle 6 are called alternate interior angles. I also have one more pair, angle 4 and angle 5. Alternate interior angles. What makes these things so special? They equal each other. And I spelled that wrong. Oops. They equal each other. If you take a look at angle 3 and angle 6, if you were to take out these other angles, you can kind of see, hopefully, that they look similar. They are, in fact, equal to each other. Now, other side of that, I have my alternate exterior angles. My alternate exterior angles on the outside, but on alternate sides of the transversal. Angles on outside, alternate side of transversal. And these, because these are labeled as well, these two equal each other. So, in our example, we have alternate exterior angles 1, 2, 7, and 8. So, angle 1, and alternate exterior angle, angle 8. Then we also have angle 2 and angle 7. So, another way to write that one, the measure of angle 1 is equal to the measure of angle 8. And the measure of angle 2 is equal to the measure of angle 7. You are going to see that with that little M in front there, and that's exactly what that means. The measure of angle. So we can say that up here too. The measure of angle 3 is equal to the measure of angle 6. The measure of angle 4 is equal to the measure of angle 5. Okay? So, let's put that in a note up here somewhere. Hope you can see this one. I think you can. M, angle sign, and the number is said. The measure of angle 1. Okay? Just one of our little notes here. Okay? Now, when it comes to, we've got one more as our corresponding angles, but these two are the important ones. I'm wondering if you learn one more in section 1, but I don't think that you do. But you know what? I think I'm going to tell you anyway, just in case you see this word. You probably have already seen it, but we'll go over that one too. Okay? Another one that we're going to go over is actually called vertical angles. I think I totally spelled angels on that one. Wow, my spelling is super awesome today. So, here we have, okay, we got that one. We've got alternate exterior angles, corresponding angles. One of these ones next. Okay? Corresponding angles corresponding angles are those angles that are in the same position on the two lines in relation to the transversal. So same position. On the parallel lines in relation to the transversal. So what does that mean? Good grief. So I'm going to actually draw a new picture down here because it will be easier to see. Line, line, transversal. And labeling it exactly the same as my other one. Okay. Corresponding angles. Corresponding angles are in the same position on the parallel lines in relation to the transversal. So angle 1 and angle 5. It is in the top left corner. Top left corner. Okay. Those, you guessed it, if you can see how they look here, corresponding angles are also equal to each other. Okay, so we've got 1 and 5. What else do we have? Angle 2, angle 6. What else do we have? We have angle 3 and angle 7. And you guessed it, angle 4 and angle 8. We have 4 sets. 1, 2, 3, 4. 4 sets of corresponding angles every time we have 2 parallel lines and 1 transversal. So we would say angle 1 and angle 5, angle 2 and angle 6, angle 3 and angle 7, angle 4 and angle 8. Oh, not the measure, the angle, silly. Angle 4 and angle 8. Okay? And again, they would all be equal to each other. So the measure of angle 1 equals the measure of angle 5. Measure of angle 2 equals the measure of angle 6, and so on. The last one that I wanted to say, though, here quick, is that vertical angle. Move that up just a little bit. Vertical angles are angles on opposite sides of 2 crossing lines. Angles on opposite sides of 2 crossing lines. So it doesn't necessarily have to do with the transversal and the parallel lines, but here I would technically have, again, 8 pairs of vertical angles. I would have angle 1 and exactly the opposite, angle 4. Angle 1 and angle 4 are vertical angles, just like angle 2 and, whoop, that's right, angle 3. I also then have angle 5 and angle 8, angle 6, and angle 7. What else is really important about them? Once again, they are equal to each other. Measure of angle 1 equals measure of angle 4. Which is why it makes it so nice and easy that if I know one angle, I know all the rest of them. Will you or will you not get into the actual angles here? Not exactly sure. But you know what? We'll do an example just in case. One example here. If I've got Whoops. Excuse me. Angle 1, 2, 3, 4, 5, 6, 7, 8. And let's see if the measure of angle 8 is 120 degrees. Find all other angle measures. Now, I know that I'm a big nerd, but this stuff is super fun for me. So the measure of angle 1, measure of angle 2 and 3, 4, 5, 6, 7, 8. I know, excuse me, the measure of angle 8 is 120 degrees. So what else do I know? Well, thinking about all of my other definitions that I have here. Anterior angles, those don't say anything about equal. Exterior angles, nothing about equal. Let's go up here. Alternate interior angles equal each other. So what do I have? How about also, let's see, well, angle 8 isn't an interior angle. It is an alternate exterior angle, though. Could definitely have an exterior. Oh, look at this. I numbered them the same. So I even know right off the bat. Angle 1 and angle 8 are external, alternate exterior angles. So angle 1 and angle 8 are equal to each other. Boop. Now, what else do I know? I also know that seeing as how I just went over vertical angles are on opposite sides of two crossing lines. Angle 8 and angle 5. And they're equal to each other. 8 and 5 are equal to each other. So, measure of angle 8 is 120 degrees. Oh, what else do I have here? Now that I know angle 5 is an interior angle. Well, look at that. Alternate interior angles here are also equal, what I can't spell the word other. Angle 5 and angle 4 are equal to each other. Well, howdy doody. $120 degrees. 120 degrees. 120 degrees. 120 degrees. Look at that. Well, now we might be thinking, okay, well, sure, but now what? Do you remember way back in the beginning when I talked about that whole straight line thing? Straight lines equal what? 180 degrees. Okay. Well, then, that would tell me that this line right here, whoop, means that these two angles altogether have to equal 180 degrees. I can say the same for any other straight line here, but if I've got 120 plus something has to give me 180, well, then that would logically tell me that that would be 60 degrees. 180 minus the 120 I already have. Hey, now look at you. 60 degrees. Well, now that I know that one, I have a vertical angle here of angle 3. Angle 3 is also 60 degrees. I have alternate interior angles here. Angle 6 is also 60 degrees. And another vertical angle here for 60 degrees. Here is hoping that that was a little too slow for you and that you guys could kind of see that. If you couldn't, that's okay too. These notes I am actually going to scan in as well, so you can see them on my Google Classroom if you like. If you have questions, you can totally ask in text or email or message me. I hope this helps. Any questions, just let me know.